All right, good. Hey, we're live. Hey, it's a good thing I didn't have my head tilted back. Start off with a big screenshot of me with my nostrils. That's nice. Hey, we're live.
And we're live. Welcome
And
back.
we're live.
Welcome back to another Corona Geek, where we talk about cross-platform app development using Corona SDK. I'm your host, Charles McKeever, and today we've got a fun panel. Dr. Burton is joining us from down in Abilene. He's got a brand new MacBook and can't figure out his audio.
He's got a timeout. He's been put in a corner and told to be quiet. Be quiet.
Yeah, but you can find his stuff at burtonsmediagroup.com if you want to hear from him. Also joining us is Ed Marina from roaminggamer.com. Joining us is Sergey from spiralcodestudio.com, and Stephen Johnson is joining us from zabalbastudios.com.
See how I didn't do it this time?
I know you didn't do it. I was waiting for it. I even paused. I gave you an opening. So yeah, so we were just sitting here talking about drive-ins and good old days and Star Wars and all that kind of stuff like that. But you know what? I think we need to talk about desktop app development now.
Yeah. Hey.
Or at least let everybody know that we've done 8 videos already on desktop development, which if you go over to youtube.com/coronageek, there is a playlist created that has all of those in it, and you can go back and watch everything from working with mouse and keyboard inputs to setting up your project to adding assets onto the screen, making characters move around, and then the latest videos that we did were actually, we did a part 1 and a part 2 of shooting weapons and killing zombies, which I've taken to labeling vector math kills zombies.
Vector math kills more than zombies.
Kills brain cells too.
The whole world shakes here when I laugh. I'm like Santa Claus over here. Oh, 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 no. Oh my gosh.
Well, at least it's not a Southern California or Northern California or California quake. Yeah.
It's been 10 years since we had an earthquake over here. I don't want another one.
Do you actually get any of that when they have earthquakes?
We had an earthquake back in '96, I don't know, something like that, up in DuPont, Washington, and we felt it down here in Oregon. It was quite surprising because I wasn't used to feeling ground movement here in Oregon, and it was significant enough to rock the buildings. So,
interesting.
Yeah, I've been through a number of earthquakes, but it's kind of, when you expect earthquakes, it's no big deal. But when you're someplace where you don't expect one, your brain says, "Well, what the heck is that? Is that an earthquake? What else is happening? Did something blow up? What's going on?"
Wow. Yeah, I've never experienced anything like that, and actually it's not on my bucket list.
I got stories.
Hey, does anybody have any announcements before we get started today, before we do tiled backgrounds and terrain and stuff?
No.
No?
No.
Okay, well, I will say that on Friday I went into the PERC office and sat down with Raj, co-founder and presidente of PERC. And
is that how he prefers to be called, as presidente?
That's just the way I do it.
That's not a good start. Don't do that.
No. So we sat down for 2 hours. We recorded, talked and stuff, and basically we recorded 45 minutes of Q&A from the community, questions that people have asked, things that they have been asked in the forums, things that have been mentioned on comments and on Reddit and everywhere. So that should be coming out hopefully this week. I got to get with the videographer. They have a videographer on staff, if I hadn't said that already. He brought in lighting and lapel mics and cameras and all this kind of stuff and set it up and recorded the whole thing. So it went well. I think it's going to be something you're going to enjoy, and I think the videographer, I'm pretty sure he's going to split it up into clips that are going to be easy to consume. So, yes, it's going to be a 45-minute interview, but it'll be broken down into, fun size clips so that everybody can get the answers if they're interested.
They come in little colored wrappers?
I always think of like Snickers and stuff like that when I'm saying that. Snack size, fun size, all those, yeah.
Fun size. The thing is with Snickers and those other candy bars, when they call them fun size, they should call that rip-off size, because you're not getting much candy in there. I don't know what's fun about that.
Well, see, I like them because I can either eat 1 Snickers or I can eat 20 fun size
It's almost like having a whole Snickers. Almost.
Right. It's like donut holes. You know, you could eat one donut, or you could have a box of donut holes.
Okay,
So,
that might be a bit excessive.
oh well.
For a
Um,
guy who runs 5 miles a day, that's fine.
yeah, exactly. So hey, since we don't have any more announcements, I think that's pretty much it. The only other thing I can say is that tvOS is being worked on.
I heard about this.
You know, asset catalogs are being implemented. Things like plist settings are being worked on. Stuff for iCloud, because you know the way tvOS works, it doesn't really have a whole lot of local storage. So there's some iCloud requirements that are necessary. Also, beta for OS 10. Working on getting it out of beta, getting it into 1.0. Also working on Win32, getting it from beta into 1.0. So a lot of stuff is on the edge of going 1.0, getting out of beta, which if you've seen some of the comments here lately, people are kind of like, hey, you're working on all this beta stuff and you know, you're having like, you know, pushed it live and you're spreading yourself too thin, and you know, some legitimate comments, but you know, just for those who sound like that, they can know that we're moving it to 1.0 as soon as possible.
Somebody's been watching a little bit of too much of Good Morning Vietnam there, buddy.
No, I was thinking about the Muppets. It's the Muppet Show.
No, I thought it was that character from Good Morning Vietnam.
Yeah, look at Bri. Bri's covering his face. He's like, oh my.
It's hot and wet. With a little bit of shitty and rainy. Okay, that's my only bad word. Sorry. Bleep that out. Oh well. Yeah, you gotta watch the show. You gotta watch.
Yeah. Well, it's contextually relevant. Yeah. Okay, so yeah, let's talk about terrain.
Okay. Before I get started, you made the point of mentioning that we've had 8 shows. Is that actually correct? We've had 8 shows.
I'm pretty sure. Yeah. That's what
All
I
right.
said.
So if we've had 8 shows, then I would estimate at this point, and I know this is sort of leaning forward a bit, but I would estimate that we're going to finish up this series by around 10 or 11 shows. So this is the 9th, and today we're going to cover quite a number of things rapidly, but the reason I'm going to do that is I want to push people to look at the code without digging in too deep, because I think people will get more out of it by a brief overview and seeing what it does, and then digging in and manipulating it, changing it. And also, some of the things that I'm going to cover today are not redundant, but they are things we've done in prior shows. Things with HUDs, things with, well, mostly things with HUDs. That's a lot of what we're going to talk about mid-show today. And then the terrain stuff, which we're going to finally talk about. I got that working, pseudo, but as you'll see, I'm not happy with the result, in that the source material that I'm using uses a very complicated algorithm for, it's complicated to me because I haven't figured it out. Anything I haven't figured out yet, that's complicated. So it's complicated in the sense that I have not figured it out, but the code is there, and I would strongly encourage people who maybe have a different mindset from me to take a look at it and see if they can't figure out how to make this more beautiful. So, saying that, let me go ahead and turn on my desktop and show you what we're looking at today. The game itself is starting to look a lot more like an actual game. Can you see that?
Ooh, nice. Yes.
So before we even jump in, I'm going to tell you what we got here. The things that I've added this week that we get to cover hopefully today are, I have added a new AI style for the enemies. Now we have green zombies, which are stupid zombies. We have red zombies, which are more vigorous in their attempts to kill you and track you down. So the green ones use our original AI, and they will just move to a point and then move to another point, and they have no clue about you. They see you, they move to that point, and you're ignored for the rest of the time until they get there, and then they zero in on you again and try again. Then the red zombies use the AI, and I use the term AI very loosely, the movement code from last week that we talked about, where they adjust their path every half second or so, half second to a second, and they will continually change their direction trying to catch up to you. And then the most exciting one is I added a whole new piece of movement and attack logic for the skeletons, the archers, and they will move very much like the red zombies in that they will continually update their path to you, but every time they move, what they'll do is they'll move, stop, pause a moment, and shoot at you. And then they'll move, pause, shoot. And so you get this. Right now we don't have any sound, and I need to add that, but when the sound is in there, you'll get a cue in a sense that you need to move because a bow has just been fired at you, so you need to start paying attention. And on top of this, I have added logic that will progressively make the game harder. So you start off at level 1, the only kind of zombies that come out, you'll get one zombie, it's a green zombie, and then you finish level 1, then you can have 2 green zombies, and level 3, and it gets progressively harder. Then soon red zombies will show up. Then at about level 15, which you get very quickly to get to level 15, depending on how you play, then the archers start to show up. And another thing that the archers have is, since they fire bows at you, I decided that their arrows should also kill zombies, but not archers. So you can play this, I'm just sort of giving things away here. You can play this game a little bit strategically, where you get archers on the screen, and you can use the archers to kill the zombies if you're in the right place. So you keep the zombies between you and the archers will do all the work for you while you're going around collecting gems, which is another feature that I added to the game for this week. What you see at the top here, there are 4 gem types. So what I decided to do, instead of trying to get really elaborate and do a lot of game polish and balance on this game, although I did some game balancing, is I said to myself, how do we make this game advance from level to level? What is our goal in this game? How do we make it harder? I asked all those questions. And so, first of all, the game is insta-death. If you are hit by an arrow or you run into a zombie or a skeleton, you die, the game starts over, you go back to level 1. Your goal right now for the game is very rudimentary. There are 4 gem types which are placed randomly per level, and you simply go and pick them up, and then your indicator will show that you've gotten it. And when you pick up all 4 gems for a level, the level advances and new gems are placed in the level. And as the difficulty goes up, you get more zombies being introduced. So every 2 levels you can have, so at level 2 and level 1 you can have 1 zombie. At level 3 you can have 2 zombies. And it's basically the level divided by 2 and then the lowest integer value below that. Or the highest integer value from there. So I guess I had that wrong. On level 2 you would be able to have a maximum of 2 zombies, level 3 2 zombies, and so on and so forth. You can have a maximum of 100 enemies on the screen at a time, so at higher levels this starts to get really hectic. You're limited to a very small space, although what I'm going to do next week, you'll see, currently we're using just the debug outline that I introduced in a previous show. But what I'm going to do instead is I'm going to surround the play area with trees and bushes, and you won't be able to advance into the trees and bushes. And then the zombies and archers will come out onto the screen, but they will be masked by the trees and bushes, so they'll just walk into the play area out of this forest, so to speak. That's how I'm envisioning it. I haven't gotten that part quite working yet.
Clash of Clans style.
I guess so. You know, I haven't played Clash of Clans very much. I know. What's wrong with me?
Well, that's what they limit the area that you can move around.
Yeah. Well, this is pretty common in shooters like this, where you have just a limited area that you're allowed to work in. In fact, I wanted to say that part of the reason I want to sort of hurry this up and get it done in the next 2 or 3 weeks is because I was playing with it in its current state, and I realized that there's another game mechanic in here that we could use to make a more interesting shooter with twin stick. It has a lot of the same core elements of a twin stick shooter, except we're using the mouse and keyboard. And with a twin stick shooter, think like Geometry Wars or something like that. Well, I think if you play with this, you'll start to see the DNA there, but you'll also see that a twin stick would be a nicer interface to this, assuming that you make some changes. Let's see. Additional things that are introduced. Let me unpause here, and hopefully I get lucky when I shoot this guy. Let me advance the level to a higher level so I have more enemies on the screen so you don't have to wait for me to reproduce this. Go into Common, and in Common there is now a variable called Start Level. So I'm going to change Start Level to 15, put it right up there where I get all of the enemy types, and I'll restart. Now I can have up to 8 characters, I believe, on the 8 enemies on the screen, and you'll see that when I shoot these guys, every once in a while, one of them will drop a chest. Hopefully we get lucky here and get a chest any moment. Never fails when you're trying to demonstrate something that it doesn't happen, but I'm sure we'll get one. You've got a 20% chance of dropping a chest. Here, we got one. So, a 20% chance of dropping a chest when you kill one of the enemies. Here's another one up here. And I can't remember what the order is, but I think white chests are mouse traps, red chests are spike traps, and then blue chests are leaf storm traps. Now, each of these traps are not yet hooked up. Next week we'll see these hooked up. But as you progress through the game and pick up these chests, you'll get more and more of these traps. And then what you can do is right-click and drop the currently selected trap if you have one. Now, we have no mouse traps, but if I had a mouse trap, I could right-click and drop one. And then the way these traps are going to work is the mouse trap is a single-use trap. An enemy will run into it, and it will trigger and take out that enemy. So what you can do is basically leave behind a trail of these things to protect you from behind. Then the next trap type is the spike trap, and the way that's going to work is very similar to the mouse trap. You'll drop it with a right click. Let me get rolling again here. Okay. So you would drop it. You use the tab key to select the different traps. So you see me changing the HUD there. So assuming that I had spike traps in my inventory and right click was hooked up. It is not yet hooked up. Assuming that were the case, I would right click and drop a spike trap, and then this would function similarly to the mouse trap in that it would be triggered every time an enemy ran into it, and it would get a certain number. I haven't decided yet, like 3 or 4 hits, and then it would be destroyed. So like this, the mouse trap is a single use, the spike trap is a multi-use, multi-kill trap. It can take out more than one enemy. And then my favorite one will be the leaf storm. What this will do is when you drop it, it'll immediately home in on the nearest enemies and continue to cycle through its animation. And every time it hits an enemy, it will destroy the enemy and fling it off in some random direction, and then move on to the next enemy for a certain period of time, like 2 or 3 seconds. So it's a very destructive trap that will home in on the enemies. So unfortunately, I didn't get a chance to put it in because it would have been really cool to show in this Hangout. But that's what we have to look forward to next week. All right. I think that's everything that's coming up and everything that is currently in here. As we play around with this, you'll get to see the archers, and if the archers do not come in quickly enough, I'll adjust the code so you can see it. But speaking of the code, why don't we take a look at some of the code that I want people to investigate this week. And the first code we're going to examine, let me put this back down to level 1. Let's restart the game. And let me talk to what we're seeing here. I'll pause it. So what we see here is one of the ground styles. And it's maybe a little bit hard to see in the video. Let me see what I see over here on the... Yeah, you can see it. So it's a repeating pattern of textures that are seamless, and so they produce a nice ground pattern. And what you've got going on here is I've selected random tiles from within a very small set of tiles in this group, which is ground 3, I think. I'll check in a moment. And these are all guaranteed to be seamless with each other regardless of which ones you select. In other words, you could choose texture 1, texture 3, texture 2, texture 3, and they would be guaranteed to be seamless, and yet what you get is this nice organic pseudo-random looking background. One of the things you see a lot in the tiled games that use seamless textures is that the artist who has done them or the programmer who is using them is not, how do I put it? They are not experienced enough, or they don't care for whatever reason, and they don't lay out the tiles in such a way that it looks nice. What you get is a lot of banding and repeated artifacts. Um, in fact, I think there is one texture in here that does that regardless. Let me see if I can find it. No. Give me just a moment.
But it's interesting to see how easy it is to swap backgrounds.
Yeah, so what you're seeing here is in Game Lua, there's a section where it says Draw Background. And I'll just explain what this line is. This line is telling the background maker, use the S2 group. There are this many different groups of associated textures. Blob 0, Blob 1, Dirt 0 through 3, Grass 0 through 3, Plant 0, Plant 1, Ramp 0, and then Stone 0 through Stone 5. As shorthand, I've given them just tiny short notation B0, B1. And then, in fact, it's worth noting that although I use these together, I use them alone. I only use the blobs by themselves. I only use Grass 0 by itself. Many of these can actually be combined, but that is another level on top of the complexity which I was trying to solve that I was unable to get to in the time that I had available to me. It wasn't worth it for this example to try to solve this complexity. And I'll show you the document in a moment that you need to look at. If you're watching this video and you feel like taking a stab at improving this code, then you'll want to read the document first. Okay, so what I was saying here is this shorthand notation off to the right for people who want to experiment is saying you could put in B0 through B1, D0 through D3. So in other words, D2 would be a possibility out of that set. And then you would reload it, and you would get D2. So D2 is not that beautiful looking to me. G0 through G3, P0, P1, R0, that's only one in that set, and then Stone, which has the most, S0 through S5. Let's see. Let's go back to the one I liked previously, P2. All right, so I'm not going to be able to demonstrate the banding here, but banding, you know it when you see it. Basically, it's a repeated pattern where you see some kind of artifact. For example, let's call this little bit of stone here an artifact, and you just see it repeated over and over and over. And it looks bad. The eye picks this up. It's the kind of thing that
it's an obvious repeating pattern that distracts.
It's kind of ugly. It's a sign that people are either new to what they're doing. I mean, even here, there's a little bit of repeating pattern. You can kind of see it. Mm-hmm. I mean, this is clearly repeating in several places. But because of its random organic layout, which is changed every time, let me go with a different texture here. Here's a good one that demonstrates it. So you got like this little layout. If you pay attention to this part here, the next time I load it, I won't move the cursor. Now it's changed. So basically, I am laying out random tiles based on very simple rules that I have come up with, which are derivatives of very complicated rules in the document. Let's look at that briefly, and then I'll show you the code. The images folder has a subfolder called Lost Garden, and below that ground. And in here you will see 253 different textures for the different ground styles. And let me find it. Here it is. There's a PDF document in here called Layout Rules. If we open Layout Rules, and I bring it over onto the screen so you can see it, you'll see that it elaborates on the names of the texture files. And the names of the texture files have components, where AA is the first two letters, BB is the second two letters, C is the next one. And then it tells you, in short, what these are. So AA is the group type, and that would be familiar as D3, D3, G0, basically those subsets that I was just using to select them. And then within that, um, transition twos. Now, transition twos, at first you, let's see. Transition to is a rule that tells you what other group type you can transition to from this. So if, for example, we're in B0, this group type may be able to transition to G0 or X0 or whatever the subtype is. This is the part where I was saying you actually have the ability to transition from one style of texture to another style of texture, but you got to pay attention to the naming rules. Now, I did not incorporate this in my selection logic because it was just too much work for me. But I think that somebody maybe a little more clever or with a little more time on their hands than I would be able to do this. Because once you open up the door to transitioning from one style of texture to another style, you're going to get a much more rich background. In essence, what has occurred here, long story short, is that after I put in all the rules to deal with as many of these factors that I could, I found that in the best of cases, I only had 4 textures that I could switch between out of a group that might have 50 textures. And the reason is because this next rule, tile type, is very limiting without the ability to transition from one ground style to another ground style or texture style. Now, in short, what this tile type thing is telling you is if you are moving to the right and you've got a texture that has a tile type A, then you look at these 2 values right here, 0, 1 on the right edge. And an A can align with an E, because an E starts with a 0, 1 on the left edge. A G starts with a, no, where's another one? An
H.
L. So this is a way of saying how can I move to the right, to the down, up, etc. And in short, as long as the 2 tile matches whatever direction you're coming from. So if you were moving up, then we were looking for a tile that had 0, 0 on the bottom, which would be C. So we could move up into a C, an F, or an M. And it's worth noting that the M's are the omnidirectional 0 tiles. Anything 0, this is sort of like the base tile. So this is already becoming perhaps sort of complicated if people are not familiar with. They'll look at this and see binary, and this is not what it is at all.
Is that to represent, because it's 4 numbers there? Is that to represent left, right, up, and down, or like the corners, or?
You can think of this more like like a pattern. Forget that there are numbers here. These could be symbols too. Okay. All it's saying is that if you want to move right and you're currently in an A-type tile, then the tile that you move to must have this pattern on the edge, 0, 1. But it must be on the left edge because we're moving to the right. The next tile that lines up with this must have a 0, 1 style on the left edge. So again, an A can move into an E because an E starts with a 0, 1 on the left edge. And an L. So those are the 2 options. An A can transition to the right to a L or a E tile. And then an E tile can move into continuing to transition to the right, can move into a D, an H, and an M.
Okay, so that definitely, I mean, it kind of makes sense, but it takes a lot of concentration. Yeah, it's a lot of concentration.
You have to make a set of rules. I'm going to show you the code that does this. I'm going to point people to it. I'm not going to elaborate too much because people have to dig in and look at this document, look at my code. Go, what's going on here? Why is he doing that? Oh, it's not one of those things that I can force you to understand or talk for an hour and you'll get it. It's either you're going to get it or you're not going to get it. So let's take a look at the code.
I wish you'd force me to understand it.
I would force you to understand it if I could. All right, I'm just going to briefly run through this code. So the Lost Garden code is the one that enumerates all the different texture types. First thing it does, it has a big list of all the textures. And then it has some tables that I'm going to use, and what I do is I will study the name of every texture and strip out the parts, like it's a blob 0, or it's a whatever a P, let's see, a stone 2. And then I'll grab the group type transition to, and I'll strip out the tile type. And so I look at each of these, and I create a list of the known group types, transition tos, tile types, version types, mods. And then I reparse the whole list, and I identify every single texture by its name, and then a table that enumerates the specific components. I've broken it out in advance, so I don't have to parse the name every time. I parse the name one time, and then I have a table that tells me this texture is a group type whatever. This texture has a transition to of whatever. So in the future, for example, tile type, this 0110 nonsense we were looking at over here, not really nonsense, but confusing bit perhaps, is stripped out. And then in the future, I can simply look at the tile type and make some kind of decision based on that. Next, I created a table that I called easy group types. And really what it was just a simple shorthand notation, as I said. So later I could pass in B0 and I could pull out blob0. For what purpose, I do not recall.
Certainly makes it easier to read.
Yeah, I wanted to make it easier to read. And I might have used some of this as purely as documentation, so you see me printing out the group type below instead of looking at it and saying, what's S3? Oh, stone 3. Anyways, let's move on. Forget about this. Okay, so forget about that. I want to find a code that does it. Here it is. Okay, the way I lay out these tiles is I lay them out from the upper left-hand corner, and I move to the right. So I lay out one row of tiles, then I come back to the left, and I lay out the next set of tiles. So my tiles, when I'm laying them out, I'm going left to right, come back down, left to right, etc. If you could watch it happen, you'd see a progression of tiles popping in. And so I'm either moving to the right or I'm moving down. The only time I'm ever moving down is when I go back to the left and I need to look at the tile that was above me. And so, since I only care about to the right and to down, I created two tables. One is called allowed below, and the other one is called allowed to the right. The basis of these tables are saying, let's look at allowed to the right because this is the one that gets used more. Allowed to the right is saying, if I'm currently on an A tile, let's look at the documentation, so an A tile, what tiles am I allowed to select to the right? And I predefined these. I created tables for each. I went through and read the document, and I said A can go to E and to L. So I'm on a tile. It's an A type. I say, what am I allowed to move into next? E and L. And then using this information, I look at my current group of tiles, and I say, okay, are you a E tile? No. Ignore it. Are you an E tile? Ignore it. Are you an E tile? And I just randomly go through these tiles until I find one. And I say, oh, found an E tile. Or I found an L tile. I can use that. And I drop the next tile. Then I move to the right. And let's say that I moved into an E tile. Then I would be in an E tile. And I'd say, I'm still moving to the right. I'm going to lay out another tile to the right. So what am I allowed to do next? I'm in an E tile. Now I can drop a D, a G, an H, or an M. I got a lot of different choices here. So then I randomly select a tile out of my group and say, are you a D, G, H, or M? No. D, G, H, or M? No. D, G, found one. I found an H, for example, just randomly. So now I move to an H tile, and I continue to repeat that. Now I can lay out an E or an L. If I lay out an L, I can lay out a B, I, or a J. And then I'll get to the end of the row, and then my algorithm, which you can dig into below, will take us back to the left, change our X position back to the left, and say, what was the last tile that I laid down above this position? It will find that, and it will say, okay, let's say that the tile that was on the very left above me was an F. Well, then I can lay out an A, an E, an H, or an M. I'll randomly select one of those out of my group, and then I'll start going through the allowed to right selection again. So as you can see, mostly it's what tile am I allowed to select to the right, and then which tile am I allowed to select down? And actually, this is not true. If you're thinking about what I'm saying, you're thinking, yeah, but you have to match the one above you too. So in truth, there's a loop down here, which I will encourage people to read through instead of having me enumerate it, that simply goes through and looks to the right, it looks up, and it makes sure that the tile it selects matches both. So my initial example where I said it looks only to the right, not exact, or I'm sorry, it tests only for the right is not true. It tests for the right, and if there's a tile above, it reduces the set of choices to ones that match. In other words, let's say you had a tile. This is very hard to describe without a physical representation. Let me see if I can do this. There's another document you can look at. This one here.
Ed, are you creating the background in one loop?
So I'm sorry, again, please?
So I'm trying to understand if you're creating the background or you're choosing all these tiles to create entire map just in one loop.
Yeah, it's a loop where I am looping.
So it's
a loop within a loop.
From top left,
Top left.
then you go all the way to down right, and you have your entire map, right?
No, I go all the way to the right, and then I come back to the left, and I do the next
right.
row. Yeah, it's a
row by row.
Row by row.
Mm-hmm.
Yeah. Well, it's column by column.
Usually, as I remember, such backgrounds are created a little bit differently. So you first fill up the entire canvas, let's say it with some initial style, like just dirt, and then you are sprouting some little pieces of grass, of stone, of something else on top of it randomly, like you filled the canvas, then you put in, like, in top left corner there's going to be some stones, in top right there's going to be some blob of grass, and then you, from these seeds, you sprout it to some bigger areas, and sprouting algorithms can be different. For example, stone can generate some rectangular forms, and grass can be like viney, all the stuff. And when you create these areas, you go to the map once again and you smooth out edges of these areas so that they will be smooth and transitional from one genome to another genome.
Yeah, no, I could have done that, except for the fact that I didn't have the ability. I did not add the ability to transition from one style of graphic to the next. You're all in Stone 0 or Stone 3, and that is it. And so with that as your only selection group, I did not have the ability to randomly lay out tiles and then evolve what is around them until it's filled in. So it's sort of more genetic in a way, or generative. It made more sense to approach it linearly, which is column by column, row by row. Otherwise, I would find myself in a situation where I would have laid out 3 tiles that had no adjacent tile that was allowed, and then I would be stuck.
So the other thing that I see here, right, is that this is because you've got a subset of tiles that all fit together. Mm-hmm. But if you had just one tile that was fairly seamless, that you could just run through and just fill in the background with that.
You could, but it would have to also that tile would have to match with any other tile in your set. And this set of tiles doesn't have that kind of flow. I mean, there's not like one base tile that matches with all the other tiles. It's got multiple tiles that can seamlessly merge into other tiles, but not any other tile.
Yeah, it's meant to
so you can
create
define
complex
additional rules of creating, like this one genome and it must be covered with another genome, like, for example, jungle to grass transition, right? You can't transform jungle to dirt. First you have to go through grass, like that, right?
Right, yeah, absolutely, you can. That's what the let me go back to the document here. That's what the BB segment of this is. it allows you to change from one group type to another group type. I'm not transitioning from group type to group type. I'm staying within the same group type, sand 3, grass 2, whatever. But if I had the time, it's all a question of time. I didn't want to invest too much time and effort in this because the ground was not a driving factor as much as some of the other elements, which is like pickups and movement and things like that. And so I didn't think it was worth the time to do additional labor selecting a very complicated algorithm that when I finished it, nobody would be able to read anyways. I mean, the one I've already got is getting pretty hard for folks to read. The thing is I could make it better, but then I had to spend more time on it. It's always a question of time. So I didn't think it was worth the investment to go beyond basic transitions to new tile types within the same group. So it makes a somewhat boring background, which is unfortunate, but it's an order of magnitude more work. And for me to make it legible for people in the audience so they could actually understand what this code is doing. Okay. Not doing this a whole lot, I decided it wasn't worth it.
All right, yeah, I mean, obviously there's a bunch of different ways this could be done.
So let me just say, I want to get off this topic because, again, it's only 260 lines of code. It looks very complicated, but if you just walk through it, take your time, I think people will be able to pull this apart and kind of understand what's going on. I've also left some comments in here so you can uncomment some of these things when you run it and see what comes out in the console as far as the kind of logic it uses to select things. Total tiles. This here will print out the group that was selected. So the subgroup is basically, once it gets through all of the code above, it will have a table that's got 1 or 2 or 3 different tiles that it's allowed to choose from. And then I randomly choose one of those, and that's the tile I use. So every time I go through, it's very expensive, but because it's desktop, we don't care so much, and it's a one-time operation. I go through all these selections and create a table that only has a certain subset of all the tiles within the group that I'm allowed to lay out for this particular one. So it's very wasteful, but it's algorithmically straightforward so that people should be able to follow it. That's the best I can say.
Gotcha. Human readable.
I'm trying to make it, I tried to make it as human readable as possible so that people could grok this. People could fit it in their head what's going on without elaborate rules that say, anyways, I'm not going to go there. So what do we got here? I wanted to show you next was the enemy logic and how that works. Last week we talked about that. So that should be a pretty quick thing. And then we might have time to get into picking up the gems and going on to the next level. So last week, let me find it, we were looking at the enemy manager. And if we go down to the bottom, a bit bigger, I found that this editor, although I like working with it, is not as good for presenting code on the show. However, I'm in it, so I'm going to stick with it. Well, it's a little bit harder. The other one, I had more screen room where I could do split screen and still show it to you.
Mm-hmm.
Where are you? Okay, so last week we had just 2 variants. We had move to player, and we had another one we called move to player 2. In this week, I have changed the name of the second one to call it chase player. So what last week was called move to player 2 is now called chase player. Chase player is a piece of code that will take a few steps, look where the player is, pause, or stop the animation, and then redirect the player. So it's always chasing. So the red zombies chase, the green zombies simply move from one location to the next, and then they chase. They don't chase as frequently, basically. It's like move player is see the player, move all the way to where the player was, even if the player moves, you just completely ignore it. And then when you get there, look where the player is and move to where the player is now. Chase player is move in the direction of the player, wait a little bit, check to see if the player has moved, move in that direction, move to the new place. It's continually cycling every half second until you catch the player. And then the new one for this week is called Chase and Shoot Player. And we won't go through all the code, but it's quite similar to Chase, except that it has phases. Initially, you are chasing, and if you are chasing, you first set your mode to pausing. So that says the next time I come into this algorithm, I'll be pausing. But right now, I am chasing, and I calculate the distance to the player and the direction and all that, just like we did last week. And then if I'm close enough, I will just continue on. But if I'm not close, and it's going to take me more than 1.1 seconds to get to the player, I will perform with delay a timer. In other words, I will call a timer in 1 second, and that will execute the same function we're in. This is the same thing we did last week. And then I will set my angle, play the right animation, and start moving. So I'm chasing, set the mode for the next time, do the calculations to figure out how long it's going to take me to get to the player. If it's going to take a long time, schedule another iteration of this loop. If not, simply fall through there, set the angle, start walking, move to the player. Now the next time we come in 1 second, we'll be in the pausing mode. So the first thing we do is we cancel the transition from last time because we're using transitions to move. Then we set the next mode to be shooting, and we have already calculated our angle, etc. above, and we set the animation to paused, and this is where the skeleton will simply stand there, and then we wait 2 seconds. So when you're playing a game and you see a skeleton moving, you don't worry about it. You don't let him walk into you, but you don't care. The moment you see a skeleton pause, that's when you need to worry. As soon as they pause, you know you got 2 seconds until they shoot at you. Now, people playing the game will go, oh, I got 2 seconds. People writing the game will say, yes, I got 2 seconds. But when you see it as a player, this is one of those discoverability things. Initially, people are like, what's going on? And then suddenly the skeleton will shoot at you, and then you get the hint. He walks, he pauses, he shoots. So if I see a pause, I need to start paying attention to where that is and get out of the way because he's going to shoot at me. So 2 seconds later, we'll come back into this same piece of code, and we will not be in chasing mode. We will not be in pausing mode. We'll be in some other mode, which is shooting. So that'll be our default case. First thing we do is we set the next mode to be chasing, so the next time we come back in, he'll start walking again. But then we get this angle that we calculated above, we play the shooting animation quickly, and we call a method called fire arrow, which I have written this week. It's the very same code that we had for the player last week, except it produces an arrow that has a new body on it that will collide with the player or a zombie. So the only difference between fire arrow from last week and this week is that it uses a different collision mask to select collides with player or collides with zombies. Other than that, we set the timer and come back in 1 second and start walking. Let me go ahead and show you this code in action so this makes more sense. And the way I will do that is find the manager. Right down there. And let's make, hopefully I can do this without messing it up. I will simply comment out the code that creates anything but red skeletons. And if I'm not a complete fool, this will work. Let's go ahead and run it. Didn't crash. All right, he pauses. He shoots. He walks. He pauses. He shoots. So that's your warning. So let's get rid of this guy. Let's kill him off. Let's get up to the next level. Pick up our gems. Here you are. Okay. Even with one skeleton, it starts to get quite risky. So now we're at level 2. Another guy should come out here any moment. Let's get to level 3. Here, now we got 2. The other thing I did here is I made their arrows not quite fly as far. So as long as you're far away, you're safe. Because you don't want to have an arrow that just travels across the whole screen. Because like for example, this guy can be shooting from over there, and we don't see him, and the arrow comes and kills us, and we have no other indication, so we can't get out of the way. It's just a little bit too hard, I think. So the point of this is that there we go. We got 3 of them now. I guess I've been picking up gems and not even. I've played this enough now where I don't even think about it. I just go around picking up the gems. So we're at level 6, which means we should have 3 or 4 enemies at a time now, and they're all zombies. Now let's go ahead and change this out. Not zombies, they're skeletons, and they shot us and we're dead. Let's go ahead and actually ramp this up with all the enemy types, and I will show you what happens when you've got multiples. And I'll show you the code for balancing, which was pretty cool. I think people will enjoy this. So as far as the balancing goes, let me get this up first. Let's start off at level 50. Yeah, that should make it easy. Hopefully I didn't mess up. All right, so 50 means we can have 26 enemies on the screen at a time, and they're coming in. Ugh, okay. What you're going to see here, I'm going to try to manage this. Hopefully it's not too much for me. I've never gotten this high. I challenge people to get up as high as level 50. Okay, yeah. Level 50 might be a bit too challenging for me. I've gotten up to about level 25, and that's about as far as I can go before I just can't do it anymore. I don't have traps. You really need the traps as your second line of defense. Once you start getting traps, you'll be able to defend yourself better. But simply pausing and shooting enemies, what you find is that there get to be too many archers. Hey. Yeah, and you get to hear my my response to my own game.
All the crossfire going on.
Oh, yeah. So it gets to be really a challenge here because you can never quite see what's going on in time. Okay, here we go. I'm trying to wrestle these guys into like a circle by running around them. Whee. Okay, there we go. You saw. Let's see. Come on, shoot him. There goes the zombie. Oh, I died too. Dang it! This is too many. It's very hard to demonstrate this. But what I'm trying to demonstrate here is, come on, just shoot these guys already. They kill me. Okay, you're gone. You're gone. You're gone. Oh, jeez. There we go. Here's an archer who will help me out. Shoot! And there goes a dead zombie. So the point is I wanted to show that at some point in here you can start to use the enemies against each other. And I'm waving at the screen like you can see it. But the point, it's really hard to demonstrate on the show, but I think as people play through this on level 1, starting on level 1, they'll say, oh, this game's easy. You go around and pick up your gems. And you get to about level 15, level 16, and you're like, oh, this is starting to get kind of hard. And then you get 3 or 4 archers at about level 18, and the game gets really hard. So it was at this point where I decided, oh, we need to move this game into a new level because I can see another game evolving from here that's twin stick. And so I encourage you guys watching, if you've got time, to download this game this week and just play it through a few levels. And tell me if you don't feel like there's another game mechanic coming out of here when you get up to about level 15 or so.
And when you say twin stick, I mean, are you saying that it just lend itself to being faster in terms of interaction, or is it just because?
No, what I'm talking about is when I say twin stick is a specific genre of shooter. It's a subgenre of shooters. So a great example of a twin stick shooter is Geometry Wars. Have you ever played that game? No?
No.
Geometry Wars, I can find it right away. Pretty sure it was Geometry Wars. Yeah, Geometry Wars. So here's a twin stick game is, here's a better example. View image. Let's pop this up. So what you got going on here is this little guy here is your player, and he is shooting these bullets here. Now there's a lot of stuff going on the screen, but the right stick on your controller is controlling where you shoot, and the left stick is controlling movement. So when you move your left stick around, this dude faces, your little guy faces that direction and moves there. And all these various enemies are trying to come and kill you, and you got little background effects going on. But the essence of a twin stick shooter is movement with one hand or finger, one thumb, and firing with another. So you got firing is not slaved to the direction you're moving in. Our current game, firing only occurs in the forward direction. So when we play our game, I only fire in the direction I'm moving. Basically, I can move in the direction I'm facing, and I can fire in that direction.
Gotcha.
But you can imagine at a later level when you start to play this, it would be really nice to be able to fire behind us or to fire off to the
All
side.
this time I thought you're making this particular type of game, and now you tell me this is only forward shooting game. It's funny.
No, this has been this way for a while, for like 5 episodes. Yes, we abandoned, sometime back I did want to actually do omnidirectional shooting. What I realized, though, was the art set that we decided to go with, which is the Reiner's art set, did not accommodate a segue to that animation. In other words, if I'm walking in one direction and I want to shoot in another direction, I either have to not play the animation, or if I play the shooting animation, what ends up happening is you get this ugly transition from one facing direction to a shooting back to a walking. So I could allow it. I could still allow it at this point. I could flip a switch in the code and allow the user to fire one direction, walk in another direction. But you would see that it just looks wrong. It also adds a kind of a challenge.
When you walk, when you shoot in another direction, when you walk, you can face the character to the direction of shooting, but play the animation backwards, so he goes backwards.
But it's the transition from, okay, so you got an 8-frame animation for walking. You're walking, you're on frame 4. And then you shoot to the right. You have to make a choice. Do I start from frame 4 for the rightward shooting animation? Do I do some kind of segue? How do I mean, you could do it.
No, you just swap.
Do it, but it would be complicated. So, again, you're asking me to do something complicated, which can be done, but then I would never be able to describe how the code works to the users who are listening. I'm always limited in these talks by the things that I can describe in a few lines of code and talk to versus the unbounded choices that I have available to me if I do something more complicated.
It will look okay because the character will be always facing the position of the cursor where you will be shooting it. But when you walk, so if the character is standing like this, and you point to down right, and if you press up, it would play the walking animation backwards and walking animation, and he would go up, but his legs would go backwards, and he would face the same direction.
I'll tell you what. I'll make you a deal. Not next episode, but episode 11. We should get into the point where we remap to a controller, because we were going to do that. We've been using the mouse and the keyboard, but part of the ending process for this game was we were going to explore using the controller, the keypad, a D-pad controller, or a joystick. What am I trying to say here? Like a Xbox controller with twin joysticks. We were going to try to map that for this game to demonstrate the process of going from one controller type to another. When we do that, I will re-enable the code that allows omnidirectional shooting versus walking, and we'll see if we can make that work to see what it would look like. Okay. I'm not 100% convinced I'll be able to do it, but we'll see.
Okay. So we're somewhere between. It sounds like both of you are somewhere between. Can we do it, and can we do it in a way that we can describe to people in 45 minutes? And the two may not match. So yeah, let's explore it and see what happens. I mean, maybe As Sergey says, maybe it's just
Sergey's right. I mean, he is right. Within the visual space of every frame of every animation that the walker has, the guy has, there's a way to transition from one to another seamlessly, or through a series of adjacent animation frames that would make it look right. But the problem is identifying those adjacent animation frames and playing them properly. So there's different approaches you can take. You can take the approach that I've taken, which is to not do it at all. Or you could take the next simplest, which is you simply play linear animations and you ignore the tween frames and you hope that it doesn't look too jarring when you switch between them. Or then what Sergey was saying, which is you don't ignore the tweens, but you may do a little bit of massaging and say, okay, I'm facing the wrong direction, so when I switch back to the walking, I'll walk backwards. I'll play the opposing animation in the opposite direction, so it looks like he's walking backwards, even though I'm facing the other. So I'm facing one direction, but walking backwards, so it looks right. And then I think one layer beyond that would be to look at all of the frames and go, okay, I'm facing up, and I want to fire to the right. What are the right animation frames to play between now and the time I fire that will get me walking in the right direction, but using the right frames that looks like he's walking, turning, firing. So that's like the worst of all cases. And I would leave that kind of thing for the guy who made the original set, because he kind of knows what all the animation frames are. I'm sure there's a way to identify it. Yeah, that's like almost too far for me. That's an art programmer deal. You know what I'm saying?
Right. Yeah, it needs to work in tandem with each other to decide on the final product.
Yeah.
Okay. So that's tile terrain, chasing the player, and then.
Let me show you one more piece of code. I know we're a few minutes over, but I really want people to look. Last week we talked about the chasing. I'm sorry, the move to and the move. Let me get the right names here, otherwise I'm going to confuse myself and everybody else. The moving algorithm. So last week it was called move to player and move to player 2. This week I want you to look at move to player, chase player, and chase and shoot player and compare them to last week's code that we talked about. And what I want you to do is I want you to go into common and I want you to find this little piece of code here called common enemy distro. And I want you to look for enemy distro within the enemy manager and see how this table is used. In short, this table has 400 entries, one for each level in the game, level 1, level 2, level 3, and each one will tell you what percentage of chance you've got to select a green zombie, what percentage of chance you've got to select a red zombie, and as the levels go up, you've got more of a chance to select the red and then the skeleton archer. And it also tells you what the maximum number of enemies will be for that level. And if you want to see this table, simply go down to line 117. I've still got the SSK code in here. Run it. Bring up your console on this, and you're going to see a big dump off to the left, and then pause the game. And you can see, for example, that at level 313, you get a 33% chance to get a green zombie with a maximum of 100 zombies, 100 enemies on the screen at a time. A 66, so 33 to 66 is the range for getting red zombies, and anything after that is a archer. And if you keep rolling up, it becomes a little more interesting. Let's get up to level. Here we go. Let's start off at the top. So at level 1, you've got 1, which basically says the only thing you can get is a green zombie, because you can only select one enemy, and 1 is the highest. You're going to get 1 zombie. 2 is higher than the max enemies. Down at level 10, you got a 10% chance of a green zombie, and then 20 minus 10, another 10% chance of a red zombie, and then if you select a value higher than that, it's an archer. But your highest value is 20, max value, so you can only get a red zombie, or a green zombie. My point is go look through the code, look in common, and look at the enemy distro, and then find that. This is gonna tie into the movement and the creation. Find enemy distro, and you're gonna find every place where it is used, and it'll tell you things like how many enemies were allowed, or what kind of enemy we're allowed to create: red zombie, green zombie, or archer, or no, I'm sorry, archer, red, or green, and so on and so forth. So this is more like an assignment week. I just wanted to show people the new features and then have them dig into code that has been modified from last week with this distribution table. And then it's also worth, I already pointed this out at the beginning of the show, but another thing you can do is when you're looking at those distro levels and you want to see what it behaves like, is go in and change the start level. And just like I did in the demo, if you change it to 25 and you restart the game, you'll get a level 25 game. And a level 25 game has 13 enemies, and it should get every kind of distribution of enemy type the longer you play. They're randomly selected, but you have the odds of getting an archer. So there's our archer. Let him do some favors for us. Starts shooting our other enemies, and so on and so forth. Okay, so I went over by about 10 minutes, and I know I just briefly covered a lot of this stuff, but I'm hoping that people would be able to dig into this code and learn some interesting things from it.
Okay, and you said next time we're going to do...
So next time what you're going to see is I'm going to add a forest around here. We're going to get rid of this outline so it starts to really look like a game. And then we'll talk about the drops, which we didn't talk about. When you kill an enemy, they drop a chest. They got a 20% chance of dropping a chest. And then you'll walk over a chest and pick up the chest, and you'll get one of these trap types, and then we'll end off talking about the traps and how to drop them, and you'll see them in action doing their damage. Next week what we'll have is a completely playable game that progresses level to level with insta-death that takes you back to level 1. You'll have all the traps. You'll be able to use the traps. And yeah, I think that's it. That's about as far as I want to take the game with features, because at this point this game is starting to need to be a different game. I feel it needs to be a different game to be more fun. And it also, when we transition out of this game, we'll be able to take this code and quickly make it into a twin stick shooter. So I'm looking forward to that, because we'll be able to do, whereas we did this one in like 10 or 11 episodes, we'll be able to do our twin stick shooter in like 3 or 4 episodes, because it's going to be all the same code, just different art and some different movement rules.
Okay, well, I think that's good. I mean, it looks like it's becoming a feature-rich game that has some interesting mechanics to it, and we've covered everything from inputs to the project to the getting things on the screen and accounting for ratios and aspect ratios and all that kind of stuff like that. So I mean, at this point, we would have fully covered a lot of the key topics for desktop development.
Actually, I have a suggestion, something I'd like to do. I'll float it by you here in the live session. So we're going to get to next week, that's 10, and we're going to look at the traps and the pickups and stuff like that. And then we're going to have a little bit of stuff left over. So we'll do the next week, we'll do the switch over to the new controller and the experiment I talked about. But I think on the week after that, and I know this is going way out, I think it's at that point that I'd like to switch over to a new game. And the way I'd like to do that is to demo whatever I've got in the new game on that week, but then do a recap on this whole session, this whole 11 segments, where I simply point out the code and show people a graph. So on previous, what was the tunnel game where you switched 45-degree angles?
Zigzag Boom.
Zigzag Boom. So I did a document for that one, which I didn't do this time around because I had no idea what I was doing. I had no idea where I was going with this game in the beginning. But now that it's fully formed, what I would like to do is give people a document similar to that says, these are the parts, this is where you find them, and just do a recap. So we can do a half-episode talk where I simply recap the major decisions you're making in this code and where the code lives, because there's a lot of code It's going to be fully commented by then, and that way people can take it apart and get the most out of it. So it's great to have the episodes where I'm talking to it, but I think for you and for them, just having a recap of the full beast might be useful.
Yeah, and I think that's fair because we've said in the past, go back and watch this episode because it talks specifically about mouse inputs. But as we've progressed, things have changed, right? So you just said a little while ago that the follow player code, you changed the name of it or whatever, right? So if somebody was to follow video to video, they'd have to be paying attention to know that, that's the same code, but the code's changed, right? So so having a wrap-up or at the end, a summary at the end to kind of say, hey, okay, here's the fully formed thing, and here's where everything lives, and here's what you need to be focused on. I think that would definitely be helpful.
Yeah, this code is significantly different now from where we started.
Yeah, not to say that somebody shouldn't go back and watch the previous videos because
no, they should, and they can get the code for the previous videos too.
Yeah.
GitHub has the ability to go back in time and look at any version. I just didn't want to maintain copies like I did previously because there's so much content that it would have made the download for this hundreds of megabytes.
Okay.
So, yeah.
Okay. Well, I think this is good. I think we're headed in the right direction. So there you go. So next week we will talk about that. We'll look at, like Ed said, we'll look at force and pickups and traps and insta-death.
Insta-death. Well, we've already got insta-death. You just
I know. I just want to say insta-death. I think it's fun.
I challenge you guys to play this game. I'm gonna commit it here shortly. But
okay.
You get to level 15, I think you're going to see another game in there. You go, oh, we need to get out of here. This is a different game now.
Okay, well, there you go. There's the challenge. Ed has thrown down the gauntlet. We have to play the game before next Monday.
I challenge anybody to get past level 25.
And whoever gets the highest level wins. What they win, I don't know. But that's just the joy of knowing that they're at the top.
Satisfaction that knowing they're a better player than I, and I made it.
You're right. Of course,
all the time, though.
Of course, we can just change the source code, maybe cheat a little bit. That's always good too.
That doesn't count.
All right, guys. Well, there you go. We'll be back here next Monday to talk all about cross-platform app development using Chrome SDK. Until then, have a great week and happy coding.
Cheers.